Set up an inclined plane. Take a ball. Push it from the bottom of the inclined plane with a speed so that it moves up. Observe the speed and motion of direction of the ball. Now, release the ball from the top of the inclined plane. Once again, observe the speed and motion of direction of the ball. We observe that the speed of the ball increases gradually on the downward slope, but the direction of motion remains constant. Decreases gradually on the upward slope, but the direction of motion remains constant. In both the cases, we learned that speed of the object will change on the inclined plane, but the direction of motion of the object remains constant. Take an object which is tied to one end of a string. Try to rotate the string in horizontal direction as it makes a circle. Now, draw its path of motion and velocity vectors at different positions. Assume that the speed of the object is constant. Observe the velocity of an object. We will observe that the object will be moving in a circular path with constant speed, and the direction of velocity changes at every instant of time. Finally, we have learned that the direction of the velocity at any point is given by the tangent to the circle at that point during circular motion. The direction of motion is therefore continuously changing, but the speed is constant. As we know that the direction of velocity is tangent to the path at a point of interest, so the velocity is not constant. In this activity, we learned that though speed remains constant, the velocity of the object changes continuously, because magnitude of velocity is constant along the circular path. The only change in its velocity is due to the change in the direction of motion. Take a ball. Throw it into the air while making some angle. Observe the speed and motion of direction of the ball. Observation. We observe that the speed of the ball decreases on upward slope and increasing on the downward slope, and the direction of motion also changes continuously. From this activity, we learn that the speed and the direction of motion both change simultaneously. From the last three activities, Activity 3, Activity 4 and Activity 5, we conclude that the change in velocity takes place in three ways, such as speed changes with direction remaining constant, direction of motion changes with speed remaining constant, both direction and speed changes simultaneously. The motion of an object is said to be non-uniform when its velocity is changing, and the motion of the object is said to be in uniform when its velocity is constant. Now, let us learn about acceleration in detail. We learned that the velocity of an object can be changed by changing its speed or its direction of motion, or both. In either case, the body is said to be accelerated. Acceleration gives an idea how quickly velocity of a body is changes. We experience acceleration many times in our day-to-day activities. For example, let a train start from rest at station A. When it starts moving, its velocity increases, and after a certain time interval, it attains a constant velocity. As next station approaches, its velocity gradually decreases and finally becomes zero at station B. This rate of change of velocity of an object is called acceleration. Here, we can say that the term acceleration not only applies to increasing velocity but also to decreasing velocity. The decrease in speed as the body moves away from initial position is called deceleration. Deceleration can also be called the negative acceleration. As per the definition, the formula of acceleration of the body is shown on the screen. If the velocity of an object changes from the initial value u to the final value v in time t, then the acceleration a is v minus u by t. This kind of motion is known as accelerated motion. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. Acceleration is also a vector and is directed along the direction of change in velocity. The SI unit of acceleration is meter per second square. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. The motion of a freely falling body is an example of uniformly accelerated motion. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. For example, if a bus traveling along a straight road increases its speed by unequal amounts in equal intervals of time, then the bus is said to be moving with non-uniform acceleration.